Now we did a wire fault where I could reach both connectors with my 3-foot meter leads. So my maximum here is 6 feet that I can get end to end. What happens when I'm greater than my meter lead length? Well, you could add a 100-foot test lead spool, zero those leads out, and then go from there. But if I don't have access to 100 feet of wire or test lead, there's another option by just simply, what every electrician does when they're doing typical continuity, they use a jumper. They're gonna jumper the other end and measure continuity from this side. Or you can do the same thing for the wire fault. We're just gonna walk through that. All right, so simply select low ohm. Low ohm, keep in mind, low ohm has a maximum of 50 ohms. So I need very high resolution voltage and current in order to not only get above the noise floor, but also have that bonding meter resolution. I need to be into the micro ohm level. So that is the only thing you gotta keep in mind. If I'm above 50 ohms on any of these measurements, it's gonna say open, right? Typically, I don't have to worry about that. I have a short to ground in this case, or a short to shield. It's less than 50 ohms. I can now use the wire fault function. Otherwise, you'd be stuck using a TDR. All right, so I'm in low ohm. I'm now going to have to set up my meter and then zero my test leads. So how do we set that up? Remember, we go into wire fault. Again, I want to tell it that I need feet. Hit feet. Now I need to tell it the length. In the case of our length, 50-foot wire run, but I'm going to go out and back. So I have to double that length, 100 feet of wire then, 50 plus 50, plus my jumper. So my jumper is about 1 foot total with the pin adapters. So when I go to B and D and jumper, let's do that right now. So I had jumper B and D, I added an additional foot, so that's 101 feet total. So 101 feet, we're good to go. Next step, I gotta zero my test leads. In this case, we're gonna zero our test leads by just simply connecting here, let it sit, and wait about 10 to 20 seconds, make sure you seat everything really good. And that's gonna eliminate this 6 feet of test lead, because we don't wanna add that into the equation. And once it's relatively stable, just hit setup, and it now tells you just measure continuity. Measure continuity of your 101 foot run through the wire, jumper, and back. So my red is gonna go to, I gotta go to A and C here. Right. Okay, I'm connected, I hit setup, and now this is gonna do the counting for me. After about 10 seconds, once it's stable, it'll give us the resistance of A to C all the way through. So 1.745 looks good, hit setup. It captured it. Now it says go A to fault. So I'm gonna go A to my problem. So my problem is the shield, the ground that's grounded. And so I'm gonna go to pin E, which is connecting my shield. Right here. All right, A to shield. And I hit setup. Again, it's gonna count and capture that measurement. So from A to my shield is 2.05 ohms. I hit setup. Now it says go B, whoop, backlight turned off. Go B, in our case it's pin C to ground. So I'm just gonna move that to the other wire. Yeah. Leaving, remember, I did not leave my fault wire. My fault wire, B to fault wire has to stay there on my pin E that goes to my shield. It's gonna do the same thing, it's gonna count looks for that stability. And now C, less resistance to this ground, 1.67 ohms. I hit setup. Now it tells you from A to fault is 62 feet. So 50 feet, 51 plus the jumper, plus about 11 feet from D to my shield here. So as I go through here, so 50 plus the jumper, and then about 11 feet more here. Now how about from pin C? From pin C, remember it's 11 feet here, and it's a 50-foot run, so then it's 39 feet from here to here. And that's exactly where we shorted this harness out. Pretty slick, pretty easy way to do this. Yeah, I definitely recommend doing it.